Okay, in this lesson we are going to graph straight lines from their equation. Remembering that the equation is in the form of y equals mx plus c. Let's have a think about what these mean. The x is our variable. It will change. Okay, if we have a look across here at our axes, this being our x, this being our y, as x changes, the y value will change. That is exactly what, that's exactly what the x is. It can be any of these numbers. It doesn't matter. It will all be part of this line. Now this c value is our y-intercept. It is where the line runs into this y-axis, okay? Every single line will be running into it at a different point. The y-intercept is when x equals 0, so it will always be on this line somewhere. The y value will change as the x value changes, and this m value equals the gradient, and the gradient is the slope or how steep the line is. If it is a positive gradient, the line is going up. If it is a negative gradient, the line is going down. Now I understand lines can go both up and down in the same way, but we're talking from left to right. If it is going left to right down, it is a negative gradient. So what we need to be able to do is take one of these and turn it into a visual representation of the line on a Cartesian plane with an x and y axis. So we've got this, we know it represents a linear equation, and that's representing a line. So there's two different ways I'm going to show you how to turn this into a straight line. Number one, we can see that our gradient, or m, don't ask me why it's m, equals 3. We can see it is a positive number, so that means the line will be going up from left to right. 3 is a whole number, that's positive as well. And our gradient actually means rise over run. Okay, so it means however much as something goes up, it also goes across. So our x and our y. We also have this number here. This is our y-intercept, so we can draw that on the graph straight away. When x equals 0, y will equal -4. So it's going to be on the y-intercept crossover. In here is our coordinate for -4 at x equals 0. So now we have to say, all right, if our gradient is 3, it means for every 3 up, it will go 1 across. So we can actually do that on this graph. We can say, all right, for every 3 it goes up, 1, 2, 3, it goes across 1. And up 3 more, 1, 2, 3, and across 1. And you can start to see that straight line forming. And you can then join the points all together a bit neater than I just did, and there is your straight line. Okay. That's one way of doing it. If you aren't comfortable using this gradient to do the rise and run, then you can do it a different way, and we've shown you how to do this throughout Year 9 as well. Here is a linear equation. It is representing a line, and here's its gradient. It is m equals -2. We know it's going to be going down. That's your first clue. We know it's going to run into that y-axis, that one being this line here at +4, so we can put that on here. That's our coordinate. It's where it's running into it. And we can actually do a bit of a set of coordinates, x and y. You've seen this before. So let's say when x equals 0, we knew that it's going to be y equals 4. We can continue to do that until we get our straight line. And now you can solve it by substitution algebraically. So when x equals 1, y will equal -2 times 1, knowing that that is our x value, plus another 4. So that's -2 plus 4. -2 plus 4 is 2. So we can do that. At x equals 1, y equals 2. You can see our line starting to form. Now let's go. When x equals 2, y will equal -2 times 2 plus 4, which is -4 plus 4, which is simply 0. So our next one is at x equals 2, y will equal 0. And we can keep on plotting. I've got 3 points there. I can make my straight line, so I will do just that. join them all together, it will continue in that direction. We can do a check and say, yes, it is a negative gradient, it is going down from left to right, and it is running into the y-axis or intercepting it at positive 4. So two different ways to take a linear equation and turn it into an actual graph. Whichever one you are comfortable with is perfectly acceptable.